Watch the news. Well, John Belsky, he's a weatherman, and they have these long-range computer models, and they're saying that, like, a week and a half from now, we're going to get another snowstorm. Heather, another snowstorm.
I'm sick of it today. I need to get out.
Okay.
I don't want to get out of the summer as soon as possible.
Snowstorm. Shh. Snowstorm. Snow again. So they're thinking it's going to snow again. It goes back to our discussion about lattice energy and sodium chloride, which would be the rock salt they put on the roads, and then the calcium chloride, which is the... Okay. Well, the calcium chloride, once again, was the stuff that you buy at the store. This is really better for fish, too. The big problem is when sodium chloride gets in the water, you have something called the sodium-potassium pump, and it can affect their, like, bodily, or I shouldn't say bodily, because they're not fiscally functions. That sounds better. So that's another reason why they prefer you to use the calcium chloride, because it's better for the environment. It's more expensive, though. They just can't put it on the roads just out of cost. It's not cost effective. So which of these two has greater lattice energy? The sodium chloride or the calcium chloride? Remember? Right, the calcium chloride has greater lattice energy, and part of that reason is because it has a higher charge. The calcium does. And this kind of leads us to this over here. Which compound has higher bond strength? Magnesium oxide or magnesium chloride? Yeah, the magnesium oxide is going to have higher bond strength because of the charge. The oxygen has a 2 negative, so it's going to give this magnesium oxide a higher bond strength. Now that doesn't mean that chlorine doesn't desire to react with things. It does. That's why it gets away easy. If you can see over here, sodium chloride is going to get away from this easily. That's the problem with it when you put it on your sidewalks, is it gets away from the sodium and then starts to destroy your sidewalk. It's bad.
Yeah, but that's what. This was from yesterday, this was from yesterday. That's a lot of that.
So if you're at the stage where you can write the answers without looking at the sheet on the board, that's pretty good. Cody has shown that he is developing some mastery of this. Now you're close with the dye, it's just going to be potassium. You only use the dye with the non-metals. And that would be sulfide.
Love it. Love science.
I like biology.
I understand biology.
What that has
See any more of this?
I thought there's like a grain of rice in my eye.
That
Well, yeah. It's something else. Same.
In this lab today, you're going to have these plastic containers that get over there. You see them. In container 1, you're going to have PbNO3, lead nitrate. Container 2, you can have K plus I minus potassium iodide. Right? Now, when you put this in the well plate, they're all going to be floating around. Now, some things are soluble, like lead nitrate is soluble in water, and so is potassium iodide. But some things are not, like lead iodide is most likely not soluble in water. You can look at the solubility charts to know. So what's going to happen, one of these is not going to be soluble and it's going to form a precipitate. What's a precipitate? I know what a precipitate is? It's a solid substance. A solid substance is going to form at the bottom of the well plate. And you're looking for the well plate that has the greatest amount of the precipitate form, because that's going to show you what the formula is. That means you're going to have the least amount of waste. So these are all one charge. Does everybody see that? So you're looking for the well plate that has the greatest amount of precipitate, and that's going to tell you what the ratio is. It's most likely going to be, if you do you can predict. Does everybody know how you can predict here what your two possibilities are? And then you're just trying to see if that's true. Does anybody not understand that? Raise your hand if you don't. So if these were our original two, right, and I mixed them and I formed lead iodide, what's the ratio here going to be with lead iodide? 1 positive to 1 negative, which is a 1 to 1, right? That's what you're looking for. In the lab today, the 6 to 6, 6 drops to 1, 6 drops to the other would be 1 to 1. Does that make sense? So the other one would be K plus NO3 potassium nitrate. That would be 1 to 1 as well.
Huh? Okay. Let's start. Yeah, there's stuff in it. Yeah, it could kill you.
There's a constant chemical imbalance. And actually, now that foam up,
Yeah. Well, actually, no, I don't. But
they foam.
My shot.
Does potassium sulfide have 2 S's?
I believe so, yeah. Yes. Nice job. That's the sulfite there, hydrogen sulfite. Actually, it's HSO4, so it's the sulfate. It's lithium hydrogen sulfate. That's how you always want to double check there. Measure twice, cut once. You can look at the periodic table. See the nitrogen there.
Is it IED?
That's right.
5 FID.
That's right. I think it's like pH.
Just like
POS, yeah, POS, PH, ID, yeah. So, no, just look it up. Let's go. Spanish food, rice,
potassium.
bromate. Yeah, we looked on the reference sheet. Found the bromate. Nice reference sheet here. Potassium bromate. Now let's look on the reference sheet for the ClO.
Oh, 3?
Yep.
Is the 3 up or down?
It's a subscript. It should be right down there on the bottom. There's that, just like you see here with that 2 that Nick wrote up there. What dangerous weapon can you make with potassium, nickel, and iron, Ransom? No. Think about it. Some of that potassium, some of that nickel,
Yes.
some of that iron,
Right.
some of that knife. Alright, so in the lab today you're going to have one container of lead nitrate, another container of potassium iodide. You're going to mix them in the well plate. They're going to float around. They're going to form this solid lead iodide. This forms a precipitate. It falls out of water, right down the color you see, and you can pour off these ions, this K plus and NO3 that's still dissolved in the water. It's just a characteristic. Some things are insoluble. There's actually a solubility chart that you can use as a reference. You don't have to memorize this. You just look for the things that are insoluble. This is how you know you can produce a product. So I could pour this off and sell this lead iodide if somebody, a customer, wanted it. If I had lead nitrate, I can make lead iodide pretty easily and sell it to them. I don't know why they'd want it. They might need it for paint or something. You'll see the color over there. They might want yellow paint. The problem is you can't put lead in paint anymore, so you wouldn't be able to sell it to them. They used to do this in houses, but then they found out kids were eating it, and that was a problem. So you can't use lead anymore in paint. So you wouldn't want to put it in paint. Good reaction there. See that precipitate formation. Make sure you're following the directions. Tomorrow we have our test on naming. Right, there'll be 50 questions. 30 will come from the review yesterday. Now on the board up here we have some of the homework that we didn't get to go over yesterday just because we wanted to focus on the quiz, so we want to go through 15 of those. Before we do that, we've been talking about lattice energy, and John Belsky, he's the weather guy. He used to be on Wave 3, now he's on, I believe, WLKY. But he gets into the computer model, long-range forecasts, and they predict that, I think February 2nd to 6th, we're supposed to get like 15 inches of snow. He was talking about that. 15 inches of snow. So, on February the 2nd to the 6th, snow, yeah.
So no school?
I don't know. This is a computer model. Now keep in mind that computer models are not always accurate. It's kind of like, you know, climate change. Computer models, there's a lot of variables that come into play. Things happen that, like there could be earthquakes and volcanic eruptions. If there's a volcanic eruption, that's going to throw the atmosphere into a cooler climate. Now, up here, we're talking about, you know, snow removal and that they use sodium chloride on these streets, and they use the calcium chloride on these sidewalks, right? It's like this. This also is better for your aquatic life. The sodium interferes with what? With fish. Freshwater fish. What happens when freshwater fish are exposed to salt water? Yeah, there's sodium potassium pump, which regulates the water in their fish, I don't want to say body, because they don't have bodies. Fish, what would be fish? Cells. Yeah, I guess they do have a body too. Kind of weird saying a fish has a body. Okay, so the salt is going to affect the sodium potassium pump, and it causes the fish to take up too much water. Or like if you were to be on a boat, you know, you're stranded and you drink salt water, it causes what?
If what?
If you're on a boat and you drink salt water, what's it going to cause? It's going to cause you to have. It's going to cause you to have diarrhea. Yeah, it's going to cause you to basically push out the water that you have in you, because it's going to. The salt is going to. Some call it osmosis. That water will move from a high concentration to a low concentration. So like the Mississippi flows into the Gulf of Mexico because of this. Water will go from a high to a low. It's osmosis. You ever heard of learning by osmosis? You ever seen the little Garfield poster where he had a bunch of books on top of his head? That would be the high knowledge, and they were saying his brain was low knowledge. It's kind of learning by osmosis. But the point is that if you consume salt water, your body is going to have the higher concentration, so you're actually going to be dehydrating yourself. You'll be taking water out of your body in the form of diarrhea. So that's not good. So be aware that the salt is bad for the aquatic life, is basically the point we're trying to make to you there. Now, the question here, which compound has greater lattice energy? Raise your hand. Which compound has greater lattice energy? The NaCl or the CaCl2, Lily? Which compound has greater lattice energy? NaCl or CaCl2? We talked about this yesterday. Well, you would want to put the more, this is more expensive. Like if you go to the store, they're going to try to sell you this because it's safer for the environment and it's not going to cause as much damage to your property. You'll see one day that you want to keep your property nice so that one day you can sell it if you desire to move. If your property is in disrepair, you're going to get low offers. That's not good. So this product, this calcium chloride, will help protect your sidewalk or your concrete, causing it not to deteriorate, because it takes more energy to break the calcium chloride bonds. Now, where's the energy going to come from? Starts with the S. Starts with the S. Sky doesn't give us energy. The sun does. Most people get out during the daytime and they sleep at night. So you put the salt out. Typically they'll do it before rush hour, so that by the time people get out, the sun breaks out, that it's done its job. So if it's really cold, they use the magnesium chloride. So the calcium chloride has the most lattice energy because of the calcium. It has greater charge. Keep that in mind. Okay, Ca2 plus, greater charge. Over here, which compound has higher bond strength? MgO or MgCl2? Which one has higher bond strength? MgO or MgCl2? This one will get away easier because of the chlorine. The chlorine is very reactive. It wants to move around like we showed you with sodium. What's going to keep it there? A higher charge. So magnesium has a higher charge, so it's got higher bond strength. This is greater bond strength. This is bonded greater than this is because of its higher charge. The O2 negative and the 2 positive has a greater charge that creates a greater bond strength. This is 1 negative. So we typically look at the oxygen when we're looking at the nonmetal. When we look at bond strength, when we look at lattice energy, we can examine the metal over here. Now, if y'all see Luckley today,
Which one?
Mr. Luckley, you better tell him that he needs to be rooting for those Eagles. These are.
I want the Eagles to lose, so.
Oh, you're an Eagle.
Why are you yelling?
Eagles have to, look out for each other. We're in the same Eagle family.
I want the Eagles to lose, so. Because I don't like Mr. Ellis' class.
I think this one's ammonium.
How do you spell it?
Just UM?
Yeah, click on the reference sheet.
Don't say that. So.
It says ammonium. Excellent. So always, measure twice, cut once. If you just have the slides down, just go ahead and recheck yourself. All right, you can do 7, 8, 9.
This was my second choice. And then magnesium. Let me think.
You work here. Look for here. CLO.
2, so it'll
It's
be.
actually just CLO. CLO.
It's hypochlorite, isn't it?
Yep, right there. Hey, just get that fast mind.
Lithium. Oxide.
Oxide, maybe.
And I.
No.
It's not I.
You have to put it in parentheses.
And then I. Hold on, let me think. Date. Would it be 3? Okay, I know 3. I don't want to. You're making me look at the paper. I want to think of myself.
Yeah, use the paper. Reference it. Don't be afraid to use your reference sheet.
It doesn't have IO date on here. Oh, here it goes. IO. Would it have the negative stuff there?
If it's -2, then it's just going to be.
It's just the mark right there.
Is it, which one is it?
It's just the mark.
Yeah, so you're going to have 2 of them. Oh, I'm sorry. You'll have the parentheses and you'll have 2 because calcium has 2 positive. Get that? Make sense?
Mm-hmm.
Lead nitrate, and you have potassium iodide. We're trying to show you that the formulas up here that we're making, this holds true in the lab. It's one to say it. It's one thing to say evolution is true, but when you go in the lab and you see it, you see that microevolution changing. Yesterday they just cloned or had evidence for cloning. I think it was they cloned a sheep many years ago, but they cloned a little, I think, monkey or something. So they've got these different processes they're working on to change chromosomal numbers, which is macroevolution, which will occur in the future. They just haven't demonstrated enough yet, but that's coming. The macroevolution changes are in the future. Most of your micro are just gene changes. You can see on the label at the grocery store, GMO, genetically modified. Those are pretty much all microevolution. So when you see it, most people don't believe it, but when you're in the lab and you're doing it, you're like, oh yeah, there's some evidence for that. All right, so when you mix these two together, does everybody see the well plate? We're mixing them together. You're going to form the precipitate at the bottom, the PI. It's a 1-to-1 ratio. Does everybody see that's 1-to-1? Anybody not see it's 1-to-1? Now the instructions say you're going to do like 1 drop of this first and then 11 drops of this. What ratio is that? It's a 1-to-11, right? So what ratios did you expect to see the most precipitate? Very good, Brendan. 6-to-6. So look for that. That's what you're looking for. On the first one, I basically, we went over the answer. That's what you should see. If you don't see it, write down why you don't. Your handwriting is very nice.
Take a pin this morning. I have 2 waffles. He started drawing something. He started drawing.
side. She's picking. Girl. Make a side. She's picking this person. Side her.
Andrew.
Does she pick the next person? She does. Yeah, this is first.
Peyton, when you made food yesterday. I was hungry. And then I get to lunch and nobody was
Andrew.
Yeah. Don't get him. There's no point.
Wow.
Yeah, Gail. Okay, so we have first juniors do 15 squats per person. The second person is mine like squat after you have the other person would do oh, I C, A, R. Okay. No,
The big one?
But it's all. Alright.
No.
Hey, it's not citizen. No. Yeah. I got my grandma 1%. That's Will you be my sponsor for AA? You're a role model. One is just Steinecker. Look at what you
For me and my brother, our names are Austin and Alicia. We're so bad that we just only did another
You mean, is this one supposed to be a pig?
We're so proud of you.
He is right here. Season.
Peyton's getting these
right
Do you want to check this from when I was absent?
As of today, I am a clean man.
I've heard that one before.
Jimmy, correct yourself, check yourself. Some people are not getting all these correct. The correct answers are on the board. Please check yourself.
What's the next thing? I gotta make up for 2 years and I didn't do it.
Did you do that one? Cesium nitride. Cesium nitride. Oh. I go get the soccer for 6.
It's up to Alyssa. She has to pick you.
Alyssa, come on down. You know we're best friends. You know we're best friends, Alyssa.
These two kids are wild.
This one will just be lithium oxide because it's metal. Metal is lithium, so you got the right. Just oxide. Nice handwriting. Oh my gosh, Jimmy.
Jimmy, buddy, you said you have results.
How'd I do that formula?
All right, so we showed you on the board that originally the lead nitrate is the one.
This was yesterday's homework, right? Yesterday.
Yeah, we're going over yesterday.
Can I do a couple of them for a couple extra points?
If Kunit calls on you, he gets to pick who goes next.
Chloride. Nope. Chloride. I'm trying to help you out. It's chloride. It's dichloride.
No, because there's a metal, calcium, tells you don't use the dye. Only use mono dye for the non-metals.
I'm being honest with you, bro. You're in my group.
Non-metals only is when you do that.
So it's just chloride?
Right.
You don't like taking help nowadays.
Wait, what are you doing?
Nice one.
Pass it. Pass the baton.
I have to do 3 then.
Yes.
Okay.
K is potassium.
You got the paper right there. Look on there.
I feel like all of us,
Okay.
the 3 of us can do all of
You're close, bro.
Yeah, but like,
Sulfide.
How do you spell
Sulfide. I'm telling you.
B-O-V-A-S-S.
I literally just told you.
I think there's 2 T's.
Hypotenuse.
No, there's just 1.
Sulfide is correct. Good job.
Good job, huh?
Excellent.
Right, now I'm picking on Gio, then he can pick on you.
Okay. Most definitely. Of course, of course.
Okay, the other day you yelled at someone.
Close enough.
No.
No.
He said
Well, with the formula, that's the only time you got to really be concerned about capital. See, that's capital lowercase. When you're naming it,
lithium.
I got this, bro. What do you think?
That's it.
He is
So
smart, bro. He has
when it's more 3 or more, it's like.
Oh yeah, this one.
You remember?
I was going to get this started because I cracked somebody or I was listening down. Because he kept touching me, like,
What do you mean it's wrong?
No, it's not. He's right.
that's right.
That's right.
Good job. Make sure you're checking these.
No, he's right. He's right.
Hey, think straight next.
You gotta do 2 more.
I get it. He's like,
He knows it. He knows it.
Yes.
You say you a hoe.
he's 11.
Hey, stop. She said it. She said it. I didn't say it. You heard him say it, didn't you? I didn't say that.
It's just going to be oxide. You don't need the per because you have metals there. Anytime you see a metal, you don't have to use the prefixes. It's going to be lithium oxide. Good job.
Do I have to put the parentheses on there?
You need to put an L there, but you got that right.
Okay.
Yeah. Lowercase.
Do I gotta put the parentheses on this?
You do, because there's 2 of them, right? Yeah, anytime you have more than one, you got to put parentheses. Good question. That's right. Nice question. You make with potassium, nickel, and iron. Shh. What? No. If I take some potassium, some nickel, and some iron, what can I make with that, Emma? It's Emma versus Sean. Seattle versus Kentucky. Who's going to win? No. Sean, what do you think? Yes. What dangerous thing can you make? No. What? No. Y'all give up? Alright, let's see who gets it first. I'm going to give you a hint. See who gets it first. Raise your hand.
Fire! I can't see the kryptonite.
If you raised your hand. Alright, what's the next step?
6 to 6.
Yeah. So if you hold it up to the light, see if you can determine the 6 to 6 is the 1 to 1. This has a name. So I'll give you 10 points. You can tell me what the name of this is. Sean? What's Sean? Sean? What's the name of this?
I'm telling you. Ferric 2.
What?
Ferric the second. It's Ferric the second.
You're close. When you figure it out, raise your hand. Think.
Steering wheel.
Driving down the road. I have a
Wheel.
what?
Wheel.
A wheel.
Iron wheel.
No.
Periodic wheel. Iron tube. This is in the portion.
Go to the amusement park. You see?
Ferry the ground. Like iron wheel. What's that called? Merry-ground. Ferry ground. What she said? Ferris wheel.
Ferris wheel.
You know what a perfect weight is? That is not an exo.
You don't need the 2. It's just chloride. And then potassium sulfide.
No, you're not doing it right. Bro, do it again. Do this. Because that is not a perfect weight. Yes, it is.
Wait, is that just 1 or 2 S's?
2 S's.
Yeah, I know.
Yep.
That's not a perfect weight.
No.
But you just said it was. How you gonna say no?
Bromide. Because the nickel's too positive, so you need 2 of the chlorines. Look on the sheet right here. The sulfite is on here. See the sulfite right here?
Okay, so that's -2?
Right, and the magnesium is positive 2, so they cancel out. It's just Mg. See that?
7 in this one?
Make sure you're 11 to 1.